We start off with some arithmetic problems, similar to the ones we did in class. Here we have absolute value. Remember the idea that the absolute value returns the distance that the number is away from 0 on the number line, or we can think of it as you evaluate the number inside, and if it's negative, then we want to take the positive value, and if it's positive, then we leave it alone. So therefore, absolute value of negative 9 is 9. Absolute value of 14 is 14. And then we just evaluate the addition and have an answer of 23. The second question is about the priority of operations. So remember, please excuse my dear Aunt Sally. Please excuse. In this case, we see some parentheses, so we'll do that first. So I would do this as a separate step. So we evaluate the parentheses and leave everything else alone. So the exponent 2 is still there. We have an exponent, so we'll do that next. 8 squared is 64. 8 times 8 is 64. So these are all equal. And then finally the addition will be our last priority. 2 plus 64 is 66. The next problem has arithmetic with fractions. So we first identify the operation that we need to perform, and we see that it'll be subtraction. And we know that to add or subtract fractions, we have to have a common denominator. So we first rewrite these two fractions to have the same denominator. Since 4 is a multiple of 2, 4 will be a good common denominator to use. So first rewrite 1/2 so that it has a 4 as its denominator. And I can do that by multiplying the top and bottom of this fraction by 2. So 2 times 1 is 2. 2 times 2 is 4. So 1/2 and 2/4 are the same thing. So in the subtraction problem, instead of it saying 1/2 minus 9/4, I can make it say 2/4 minus 9/4. Notice that I'm not doing anything in my head, I'm just replacing in the problem. And now I can evaluate this because I know that if I have 2/4 minus 9/4, that should be negative 7/4. So the fourths we don't manipulate the denominators. The reason we get the common denominator is so that we can leave that alone and do our operation just with the numerator. The last problem here is just exponentiation, so just to remind you that a 4th power means multiply 3 by itself 4 times. That's what the value means. So if I do 3 times 3 times 3 times 3, I'll get 81. We continue with our problems with fractions. In this case, we have fraction multiplication, and so the rule of thumb for multiplying fractions is that we multiply the numerators and multiply the denominators. So 2 times 7 is the product of the numerators. 3 times 11 is the product of the denominators. So on the top, I have 14. On the bottom, I have 33. And 14 and 33 have no common factors, so I won't be able to simplify that answer. So 14 over 33 will be my final answer. Square root, we want to be able to recognize small square roots when we see them. This will be helpful even for algebra problems. So we know that 36 is 6 times 6, so therefore the square root of 36 is 6. In problem number 7, this is just a simple fraction problem, but as our first step, we should write these not as these mixed fractions or mixed numbers, but as improper fractions. So we first want to rewrite 2 and 4/5 as 14/5. Now the way I'm doing that is essentially common denominators. 2 and 4/5 really means 2 and 4/5. So this expression is just shorthand for 2 plus 4/5. So to do that, I would rewrite 2 as 10/5. In other words, get a common denominator for this problem of 5. So 10/5 is the same as 2, 4/5 is 4/5. So I have 10/5 and 4/5 is 14/5. If I play the same game with this expression, this is 1 plus 4/9. So that's 9/9 plus 4/9 is 13/9. So that's the first trick, is to get the problem written as a sum of improper fractions. Once we have it written that way, we do it the same way we did the other problem, which is going to get a common denominator and then just do the addition. In this case, the numbers are going to get a little bit unwieldy. In order to get the common denominator here, I have to first decide what that's going to be. A common denominator of 45 will work. because 45 is a multiple of 5 and 45 is a multiple of 9. So any common multiple of the denominators that you see will work as a common denominator. To make the first fraction have a denominator of 45, I'll need to multiply the top and bottom by 9. So I need to do 9 times 14 over 9 times 5. Those are going to be some fairly large numbers, not terrible, but that fraction is equivalent to 14 fifths. The second fraction, I'm going to multiply the top and bottom by 5. So this fraction, 5 times 13 over 5 times 9, is equivalent to 13 ninths, but we'll have a denominator of 45. So my last step now is to do the arithmetic in the numerator. My denominator, I know is going to be 45. 9 times 14 is 126. And 5 times 13 is 65. So 126 and 65 is 191, and my denominator remains 45.